All right, we are going to focus on question 3, which dealt with the risk and the physician's health study. Now, the researchers and the physician's health study designed a randomized clinical trial to determine whether aspirin reduces the risk of heart attack. So this is the question that we are focusing on here. And researchers randomly assigned a large sample of male physicians to one of two groups. They either took a low dose of aspirin or they took a placebo, and this was double blind, meaning that those who took the medicine didn't know what they were taking and those administering also did not know. Now we have some categorical variables where our explanatory is the treatment and our response is the medical outcome. Now, the question that we're focusing on is, does aspirin lower the risk of having a heart attack? Because our explanatory variable is the treatment, we're going to be dealing with these totals here and whether or not there was a heart attack happening for aspirin and placebo, and we're going to be comparing the two. We need to compare the two conditional probabilities of the probability of having a heart attack given that aspirin was taken versus the probability of having a heart attack given that a placebo was taken. Now, we are going to be using the percentage of change to determine whether this is happening. The joint probability that we have when they're asking us about joint probability, that is the and of having a heart attack and taking aspirin. Therefore, the joint probability of having a heart attack and taking aspirin is 139 out of 22,071. Notice that when we're calculating our joint probability, we are taking the total of the intersection of aspirin and heart attack out of the total number of individuals in the study. The risk is something that we're going to calculate to determine our percentage of change. Now, the way that we do this, the risk is another word for probability. We're going to calculate the percentage of change. And if you're not sure how to calculate percent change, I like to use the formula or that little statement of no O. So it's the new minus the old over the old, and this comes from the values that we have. So we're taking the new value minus the old value over the old value, and then we multiply that by 100%. We have to figure out what these probabilities are first. What is the probability of having a heart attack given that you took aspirin, and what is the probability of having a heart attack given that you took the placebo? Okay, well, the probability of having a heart attack given that you've taken aspirin is 139 over 1,000 or 11,037, which is about 13.013 thousandths. The probability of having a heart attack given a placebo is 239 out of 11,034, which is about 22 thousandths. Applying our formula for risk, we take the new value over the old value minus the old. So we're talking about our new value of taking aspirin versus the placebo. Placebo is your standard. We take 0.013 minus 0.022 and divide that 0.022, and then we're going to multiply that by 100. And notice that you're going to get a negative, which is a decrease. That gives us a value of about negative 0.41 or 41 hundredths, or about 41%. The risk is reduced by 41% when you take aspirin. That means that you should take your aspirin then. Now, when we're comparing risk, we're comparing it to a reference risk, so to a non-treatment or existing treatment that we want to prove, which we did in our risk assessment, but when we were comparing it to our new treatment to our reference risk. The one way to write this, aside from using N minus O over O, is to say your percentage of reduction in risk is equal to your new treatment risk minus your reference risk. New treatment was the aspirin, and our reference risk was the placebo that we were talking about. We're going to create a two-way table now based on some proportions that we have for questions 4. Let's create our own two-way Let's create our own two-way table from given proportions. According to the National Center for Health Statistics, there's a 20.3% probability that a randomly selected resident of the United States aged 18 or older is a smoker. In addition, there's a 44.5% probability that a randomly selected resident aged 18 or older is female, given that he or she smokes. So we have a given statement here. And that we have an and statement or a joint probability. So 20.3 is 18 or older and a smoker. And then we know that 44.5 is female given that he or she smokes. So we need to create a table that talks about gender and also talks about whether they're smokers or not. So create a table. We're going to construct an empty table framework from the appropriate number of rows and columns. We'll be dealing with two genders and two different types of smoking status. We have male and female, and then we have smoker and non-smoker, and we labeled the rows and the columns. Since all the data we're given in the scenario are percentages, we can construct a hypothetical sample size. It should be something large, so we're going to total that to be 1 million. Now, notice that I don't have any spaces for totals here. You could do that here. We're given an overall probability that someone is 18 years or older and is a smoker as 20.3%. It doesn't tell us whether that's male or female. That's just an overall total, which means that our total here is going to be 20.3%. But what is 20.3% of 1 million? That would be 203,000. Now, that means we also know what the non-smoker percentage is. It would be 100% minus 20.3, which is 79.7%. Multiplying that by 1 million, we would get 797,000. We know some information about our explanatory, and we know information about our smoking status now totals, but we don't know in particular percentages. We also are given that there's a 44.5% probability that the smoker is female given that he or she smokes. So I'm talking specifically about smokers here in this column. And I know that I'm talking about 44.5 as a female. But I'm not talking about 44.5% of 1 million. I'm talking about 44.5% of the 203,000 because it's a conditional distribution. So you're going to take 0.445 times 203,000 and you'll get 90,335. 90,335. To find the males, we subtract that from 203,000 and you get 112,665. What we don't have is information about non-smokers. This is as far as we can go in terms of interpreting our values for male non-smokers and female non-smokers. And that's all we have today.